Okay, Dijkstra's algorithm to find the shortest path of a network. So the first step you do is you form a table. All right, now where it's starting from, which is A in this case, put it in the column, so that column there, and everything else should go in the row, so which is the top row. All right, so that's going to be letter B, C, D, and E. It's not necessary to put it in alphabetical order. However, it's a lot easier when you put it in alphabetical order as they come. So that's B, C, D, E. All right, so we're going to say, so what is the distance from town A to town B? So that's 16. That's direct connection. From town A to town C, there is 12. From town A to town D, there isn't any connection, any direct connection, I should say. From town A to town E, there is no direct connection. You just put a cross. So between these two numbers, pick the smallest weight, the smallest number. So 12 is the smallest weight, or put a square to say that that's the one you picked. All right, so it comes from C, town C. So put the 16 down again. So we're going to say from C to D, from town C to town D. So that is already 12 has been covered. Then from C to D must be 20. So we put 20 there. From town C to town E, there isn't any direct connection. We put a cross if there isn't any direct connection. So now put the 16 down. So let's move on to letter B. From town B to town C, town B to town C. So that's going to be already, it has covered 16. So 16 plus the 11 would be 27. Okay, from B to D, from B, so B already covered 16, to D, letter D here, so that's going to give me 29. From town B to town E, if I go up that way, so that gives me 31. So now we have, so remember town D coming this way was 20, so we get town D, we get the 20, so 20 is actually smaller. We actually get the 20 down rather than the 29, because the 20 gives me the smallest rather than the 29. All right, now D, letter D, so 20, and town D, from A to C to D was 20, then from town D to town E is 30. We can keep going and check all the other options, but as far as this calculation is concerned, it looks like 30 is actually the smallest. So the smallest number is 20. So it comes from letter D. So it comes from D and E, D. It comes from D. Then go across, up, go vertical up, getting all the 20s, then go across, which is C. It came from C again, then go this way here, which is A. So that's going to be A, C, D, E. That is the shortest distance, which is 30 kilometers. All right. Let's look at another example, which is based on this concept of minimum spanning tree. Oh, this is the second example. Again, we're gonna form the table again. Let's do our table. And remember that that's where we're starting from. That goes on the vertical axis, which is the column. So all other vertices originating from A should go on the row, the top row. So that's letter B, C, D, and E. So much easier to put in alphabetical order. So the first direct connection between town A to B is 16. A to C is 8. A to D, you put a cross, there isn't any direct connection. Likewise, A to E, there isn't any direct connection. So between these two numbers, pick the smallest one. So in this case, the C is the smallest. So we put the C down. Alright. From town C to town D, from town C to town D, and C to D is 14. Well, we could also come this way, but this gives me the smallest weight, so I take the smallest weight. Alright, now from C to E, there isn't any direct connection. We're just going to put a cross. So always take the smallest weight. If there are a couple of options to get to a city, take the shortest. After all, that's what Dijkstra's algorithm is. If you have to do a delivery, you take the shortest path to get you to your destination. Alright, get the 14 down again. So if I go with the letter D now, so D to E will be 28. We could actually say D to E because already D has 14 in it. And if I go up that to that, that's not going to be the best option. Alright, let's now check. We have checked C and D. So if we check letter B, town B, and see what will be the other option, what will be, how long will it actually take to get town E going through town B. So B, remember, was 16 from B to C. Well, from B to C will be 27, 25, I should say. From B to C will be 25. From B to D, so 25 is bigger, so we're not going to take the 25. Obviously, we take the 8 because the 8 is actually the easiest to go. Yeah, if we go that way. So now, from B to D, will actually give me 26. From B to D will be 26, so that will be 26. From B to E will give me 31, so it looks like 28 is the shortest path. And that shortest path came from, so this is our shortest path. If we circle the shortest path and we go across until we finish all the 14, because the 14 came from D, letter D, and we go across whereby the 8, and we go up, finish all the 8s, and we go across. So that means A, C, D, and E will actually give us the shortest path, which is 28 kilometers. Alright, let's have a look at another example, which is more of like an exam type question. So this is a VCA question examination 1, and that was 2014. So this one actually requires us probably much better to label it. You can scan it. If we call this one as to be H, and we call this one B, C, D, E, and F, and S, because that's the school, and we label it that way, so that is a lot easier. And I want to find out the shortest path that Stephanie could write from home to school. So if we put the table again, and we started from home, and that's going to be home will be H. So A, so this one requires a little bit more. So C, D, E, and S, which is where we finish. All right, from home to town A is 6. From home to town B will be 3. And from home to town C, there isn't any connection, say. And likewise, D, E, and S, we're just going to put crosses. So we pick letter B, or town B. So letter B there, up there. Okay, so from B to A will be 5, because between 5 and 6, 5 is actually smaller, so we pick the 5. All right, from B, so still we keep the 3, and B to C, there isn't any direct connection. We're just going to put a cross. B to D will be, because D is just this turn up there, so that's going to be 11. So B to E will be 16. So B to S, there isn't any direct connection, so we're just going to put a cross. All right, so we're going to move on to our next letter. So A, which is 5. All right, now from A to B, well, from A to B, it's going to be, well, A to B is actually the, we're just going to keep the, there isn't actually a direct, well, we're just going to keep the 5, actually the 3, so from A, we're just going to keep this one here. From A to C, will be, from A to C will be 7. From A to D will be 8. From A to E, well, there isn't any actually direct connection, so we're just going to keep the number we had at the beginning. Okay. A to S, there isn't any direct connection. All right, we have done A, we have done B. We do now C. So we get the 7 down. From C to D, from town C to town D, and that's going to be already 7. We have 7 because you can get this way. That's 5. 7 plus 2 is 9. Put 9 there. Well, 9 from 7, so this is actually the smallest. So this is going to be from town C to D. What am I? C to D. Or you could actually count this way here, which is 8. That's 8 plus 2 is 10. So the 9 is actually shorter. So that's going to be from here to there, that's 5, plus 2 is 7. 7 plus 2 is 9, so you take the shorter distance, so 9 is the shorter. From C to E, Well, there isn't any actually direct connection. We're just going to keep the number we had at the beginning. From C to the school, town C to the school will be, we had the, actually we had was from C to town, from town C, so that's going to be 15. So you had 7. We already had 7. 7 was the smallest to get to town C. So 7 plus 8 is 15. All right, let's go and check the next one. There's no need of writing those ones. Okay, now we're going to check now town D now. So town D was 9 actually up there. From town D to town E, D to E, it's going to be D to E. But we had actually D, actually the smallest we could get was 8. So we're going to take the 8, because 8 we managed to get 8. So we're going to take 8 rather than the 9. So 8 plus 4 is 12. Because 8 is actually the smallest weight we could find in that. So we take the 8. All right, from town D, to S, D to S, so we could take the 12 that we already have, plus 2 is going to be 14, that is the smallest option. Yeah, 12 will be the smallest in there. What is the other option? Yes, 12 will be the smallest option. 12 plus 2, which is 14. 14 will be the smallest option to get to town, to the school. All right, so the minimum. So what is the shortest time that will take? That it will take Stephanie to ride her bicycle from home to school will be 14 minutes. All right, hope that's clear. Dijkstra's algorithm.